Okay, my friends, so for the remainder of this playlist, we're going to create an experiment that I'm going to have you observe and create confidence intervals for. And because all of anything that you form a proportion confidence interval on is binomial. You're looking at a data point and deciding if it has a characteristic or not. So really, anything binomial can be thought of as a coin. Heads, it has the characteristic. Tails, it doesn't. I mean, it's really that simple. It's not really that simple because you have to make sure you define that characteristic well, but I alluded to that in the last video, and I'll allude to any future research methods classes you have. But let's keep it simple for a statistics class, not a research class. I'm going to show you a coin flipping. Now, it's not a normal coin. It's a coin that I've created in a spreadsheet because I want it to not necessarily flip it 50-50. And I've had a hard time over the years. I've tried to build coins that don't flip it 50-50. Here are actually a few of them. I found them recently. These were all based on the size of a quarter, but the diameter of a quarter, but you can see that they have different heights. So when you flip them, well, I never got as far as flipping them because I don't know how to flip a coin that doesn't flip it 50-50. So I decided the easiest thing to do is not to try to build the damn coin, but just to use random number generation to create a coin in a spreadsheet and then let you observe it. So let's jump in and take a look. Okay, my friends, so here we have a coin in Excel with an unknown probability of heads. So what we're going to do is we're going to flip this thing in Excel, and we're going to try to estimate how often it's flipping heads based on the results we see. So I'm going to start by flipping it 10 times. Okay, there we go. So we just flipped it 4 out of 10 times. So I'm going to write down 4 out of 10. What I want you to do right now is to go use your Excel calculator and come up with a 95% confidence interval for the percentage of heads this coin flips based on just this sample. Very small sample, 4 out of 10. Might want to hit pause on the video too, and then we'll pick up with more sampling. All right, now let's flip 10 more. Okay, so now we've got 5 out of 20. That's kind of cool. We did 10 more trials and only picked up 1 more head. Interesting. Okay, practice again. Change the values in your X and your N for these new updated values and see how your confidence interval changes. All right, let's go up to 50 this time. Let's go up to 50. Let's see what we get. Ooh, we're not picking up very many heads, are we? All right, 50. There we go. So we got 14 heads out of 50. Oh my goodness. Go construct a 95% confidence interval for this one. Okay, let's jump up to 100 and see what happens. I gotta be careful when I hold the button down and make sure I stop it at 100. Okay, I got 25 out of 100. One more time. Actually, we'll do even more trials. We'll go up to 1,000 here. We'll go up to 1,000. So construct the 95% confidence interval based on 100 trials of the percentage of time this thing throws heads. And now we'll go to 1,000 after you do that confidence interval. Okay, here we go. Let's go to 1,000. Notice the heads are changing. They're bouncing around a little bit. We're going to let this thing just march on. It's starting to stabilize. You remember how much the penny was bouncing around at the beginning of this experiment. It was bopping around quite a bit, but now it seems to have stabilized. Where does it seem to be stabilizing? It looks like it's below 30%, but above 20%, somewhere in between. I'm going to try to stop it right on 1,000 if I can. Not that it matters. We don't actually. You know what? The hell with it. I'm going to stop it. I'm going to stop it whenever I stop talking right now. There we go. 1,070 trials. Nobody says you have to have a nice even number of trials. As a matter of fact, generally speaking, you can't have that. Okay, I got 284 heads out of 1,070 trials. Okay, let's now analyze those 5 intervals you just got and see how they change as the number of trials increase. Okay, my friends, let's run these numbers. Okay, so for the first one, we ran 10 trials and 4 were heads. 4 out of 10 were heads. That gave us a 40% heads rate in the sample, p hat, with a very wide margin of error of 30%, which means we can only say that we are confident that it's between 10% and 70%. So at this point,
the coin was flipping close enough to 50-50 to make us think it's basically just 50-50. There's no reason to think, let me say that a better way. There's no reason to think it's not 50-50. It might not be 50-50, but this is not evidence against that. Okay. Let's look at 5 out of 20. What happens now? Aha! Now, actually, we've seen this one before. Ha! We saw this one before. This was when we spun the coins the first time. 5 out of 20. It's the exact same interval. 6 out of 44. Aha! We now have evidence. We now have evidence that this coin appears to not be flipping at 50-50. Although, we're still maybe it's not enough trials, right? Maybe it's not enough trials yet. Okay, let's bump it up to 14 out of 50. What happens now? Okay, that's still below 50%, isn't it? 16% up to about 40%. That's looking below. Okay, let's see. Does that behavior continue? 25 out of 100. Oh yeah. Oh yeah. This is definitely looking below 50%. 17 to 33%, and then the grand finale was 284 out of 1,070. Oh yes. Oh yes, my dear friends. Looks like it's between 24% and 29%. Now, we don't know where it is within that interval. We don't even know if it is within that interval. But the fact of the matter is we've now seen it so many times. When I say it, I mean a percentage below 50%, so many times, 1,070 times, that it's reasonable to assume that this coin is flipping below 50%. Pretty rad, huh? And it's just cool. More data, the better, as long as it's good data. Okay, let's stop for today. I think this is enough for one day. And let's get you into the homework.